All right. And so just like that, we've reached the last topic on means. So population means. There's one final topic, and that topic is, can we, just like before, determine the sample size required to achieve a certain level, certain width, right? So maybe you want your confidence interval to be smaller. So the interval that we got previously of 100 and let me see, what was our confidence interval before? Of 117.41 to 137.49. Maybe we're like, hey, that's not very useful for what we had set out to do. Maybe you want a confidence interval that's very small, very, very thin. So maybe you want to only vary by maybe 5 chemicals, or maybe 10 chemicals is acceptable. So for us right here, we have a width of about 20, right? So the difference, the gap between these numbers is about 20 chemicals. And maybe we don't want that to be our width. Maybe we just want the width to be 10 or 5 chemicals. And if you also know the confidence level, then you can go ahead and do the same thing that we did before and shorten the interval. So let's just recall that the formula for the margin of error is, so just the margin of error, it's the critical value times the standard error. So S over square root N. And our goal is going to be to determine the appropriate value of N if I were to give you the confidence level. So in other words, I know what the critical value is. And if I were to give you the margin of error that I desire. So maybe instead of 20, we want, E to be 5 or something. Then that would be a super useful interval, because you would get something like 117, and then the error would be 5. So you would go 10, so that'd be 127. Okay. All right, so that's more or less the logic here. So let's do the same thing that we did previously and solve this equation for N. So I'll go kind of fast because we don't really need to know how to do this by hand. I just want to show you where it comes from. And remember, to solve for N, we're going to go ahead and divide by T alpha over 2 on both sides. So that's gone. And so now that gives me E over T alpha over 2 is equal to S over square root of N. From here, I'm going to go ahead and take the reciprocal on both sides. So if these are truly equal quantities, when I take the reciprocal, in other words, flip both of the fractions, I should still get the same thing. So let's flip the left and the right. And that brings N to the top, which is where I want it. All right, so let's continue isolating N by multiplying by S. And now that gives you S times T alpha over 2 over E is equal to square root of N. And the last step here to isolate N is to square. And look at what we get. We get a nice formula for N. So this is that N, now that it's isolated on the right, let me write on the left first. And that's equal to S times T alpha over 2 divided by E squared. So let's just make a note here. E is given. We know how much a margin we want for, for our application, or we specified that ahead of time. T alpha over 2 is also given because that comes from the confidence level that we want to achieve, and E is the margin of error. And notice that S is in the right-hand side. So for you to succeed, you need to actually have an idea of what so we're realizing that, not only do you need the margin of error and the confidence level, you also need to know what S, the standard deviation, So that seems kind of, contradictory because we're saying we're simply trying to determine the sample size. I have not taken a sample yet. So how do you expect me to know the standard deviation? So usually this is known from previous experiments, or you just go ahead and put your best guess as to what that could be. But that has to be given. There's also one slight problem. And I don't know how many of you solve this right away. There's an issue with T alpha over 2. Because if you remember, one of the first things we have to do for T alpha over 2, for example, when we're sketching, we need to know the degrees of freedom. And the degrees of freedom uses n minus 1. So how can I get T alpha over 2 if I don't? So the confidence level here for T alpha over 2, you need n. So that kind of throws us off guard here. So for T alpha over 2, you need the degrees of freedom, which is n minus 1. And that's a problem. So what we're going to go ahead and do is we're going to say that T alpha over 2 is unknown. And the issue is because it needs n. So this is going to be our solution. If you remember when we introduced the t distribution, we said if the sample size increases, then the distribution, the t distribution, gets closer to the standard normal. So I'm going to go ahead and assume that n is large enough. In other words, greater than 30. So therefore, I can replace T alpha over 2 with Z alpha over 2. So this really just depends on you remembering the little applet that we clicked on. So let's see that again. Here we see the T distribution in blue, the standard normals in red. And notice that as the degrees of freedom goes up, the blue curve gets closer to the red curve. So if I have a big enough sample size, I'm going to be able to just say, yeah, don't use the blue curve anymore, use the red curve. So instead of the T distribution, we're now using the Z distribution. So this is one way that we get around it. And I always like to explain that because it's going to explain the next step. The command that we need to use in StatCrunch is stats Z stats. Why Z? Because we are using the Z critical value. And then you select one sample width / sample size. So again, the width is going to be the width of the, so it's going to be double the margin of error. And the sample size is just the thing that we're trying to find. So let's go ahead and do an example. It's going to be very easy. You just got to remember that for sample size, you're going to use Z-stat for mean. So example 5 reads that a researcher wants to determine the mean number of hours per week that the typical person watches TV. I'm going to emphasize the variable that I'm interested in is the number of hours that a person will watch TV. So that's your random variable. That is a quantitative variable. That means that we're going to be talking about the mean. Results from a survey indicate that the standard deviation is approximately 7.5. So there it is. Look, we know what S is. T alpha over 2 is going to get replaced with Z alpha over 2. So that's going to be okay. And then we need E. So part E, A asks how many people are needed to estimate the number of hours people watch TV per week within 2 hours. There's the keyword within. That means this is the margin. So within 2. So the margin of error is equal to 2. Remember, you're going to need the width. So the width is always 2 times the margin of error. Margin of error is 2. So my width is going to be 4. All right, we've got the confidence level. It's 95%, so that's equivalent to 0.95. And we know that S is 7.5. All right, so let's go to StatCrunch. In StatCrunch, it is stats, Z stats. Please be careful because in if you go to T stats, there is also a similar command, but you're going to be getting the wrong size. So I'm going to go to ZStats, one sample, and I'm going to select on width/sample size. Make sure you delete sample size because we don't know that. The width was 4, confidence level was 95, and the standard deviation was 7.5. All right, and check this out. We get our answer of 55. All right, so go ahead and try this again with a change here now. What if we want the margin of error to be within 0.5 and see what changes there? So go ahead and give that a shot. And that is everything that we can do with a population mean.